Hello, everyone. We're going to get started in about a minute. All right, I got 1 o'clock Eastern. Manny, you ready to go?
I'm ready to go.
Perfect. Well, good morning, good afternoon, everyone. Thank you for joining us. My name is Chris. I'm a technical sales representative for ITM Instruments. Thank you for joining us on our webinar via ITM University. Sorry. Today, we're going to be covering and going over screening for elevated skin temperature with FLIR. We kindly ask you to remain on mute and mute your microphone throughout the presentation. The presentation will be about 40 to 45 minutes, and we'll have time at the end for Q&A. We encourage you to ask questions at any time. You can use the chat feature. If we do have questions coming in during the presentation, we'll stop and take any questions that we have during, and we'll also have a allotted time at the end for a Q&A period as well. ITM and looks after all solution segments: industrial, automation, fire, OGI, building, science, drone, volume, instrument, OTS, and security. Manny has been with FLIR since 2012. Manny, I'll turn the presentation.
Perfect. Thank you, Chris. Hello, everybody, and welcome. Thank you for joining us on the ITM FLIR University training that Chris mentioned, the screening for elevated skin temperature. My name is Manny. My name is Manny Alsett. I am the Eastern District Sales Manager for FLIR Systems. I cover, all of Ottawa, Quebec, and the Maritimes. One thing I wanted to present to you today is FLIR's vision and mission statement. FLIR is the world leader in infrared technologies, and our mission statement is to really save lives and livelihoods. This is something that our new president has been focusing on the whole team worldwide of about 4,000 employees to make sure we focus on that. We always give the best solutions to the marketplace. We want to be the trusted leader. We want to make sure our products are easy to integrate and easy to use. Our screening mode that we've developed for a long time is one of the best systems available out there that's been approved by numerous health authorities. And we have a Canadian service and support center in Canada since 1965. 60% of our business is based on thermal technologies. 40% is non-thermal. Majority of our business is in the military and defense, and another portion is in the commercial or the solutions division, as we call it now. We are focused in the infrared wave band. We make products in the near, mid-wave, and long-wave camera systems for a variety of applications. You see here a firefighter using our camera. The industrial world uses the camera to measure equipment and look at buildings, traffic control, autonomous vehicles, and many more applications. This is a picture of our service center that we're very proud of. This is actually a new location we moved into 2 years ago. The old one was similar, but not as pretty as this one. We have a Cal lab since Canada, basically in 1965. We have over 40,000 units in Canada that is being operated and used right now. And what's interesting is we only have 2 technicians that service, calibrate, and repair these systems for the whole country. That is a testament to the quality of our product that are offered to the marketplaces. We can handle that many with only 2 technicians. Again, the center can repair, calibrate, do anything you need for your camera systems out there. We also have a training center at our head office in Burlington. This is a picture of the new training center that we based in the new office building. We've been training, offering the ITC training, which is the Infrared Training Center, since 1995. We have over 7,000 professionals trained with various degrees of level 1, level 2 thermographers. And as of recent, and due to the COVID, we are now offering virtual classes of level 1, level 2 in English and French that you can attend and follow through with an instructor as well. So since the 60s and as 2003, FLIR developed our systems were being used to scan for elevated skin temperature. We got our FDA registration in 2004, and then with every pandemic and outbreak, the systems have been just growing and the technology is just improving over time. FLIR has been involved in a lot of writing and document research, including the ISO standard, the ISO report 13154, which all concluded from different health authorities around the world, reputable health authorities like the FDA, ISO, CDC, and SPIAE, that the best place to measure temperature to get consistent, accurate, as close as possible to the core temperature is called the inner canthus or the corner of the eyes. Why is that? Typically, skin temperature can be affected by a variety of factors, by wind, solar, and so on and so forth. In this example, we have a face of a gentleman. The forehead measures 30.3 degrees. The inner canthus is measuring 34 degrees. The advantage of a thermal camera versus your regular laser guns that you might have seen, or any temperature guns, is you can measure temperature at safe distances. You don't have to be close to the person. It can be 2 meters, 3 meters, and so on, depending on the lens and resolution that you choose. Major advantage. And measuring in the inner canthus, to be able to do that accurately, you need a good resolution camera and lens combination to be able to see that closely. The example, we see a lot of these images being posted on the web right now of various manufacturers where they're measuring people walk into an area wearing glasses, masks, and hats. And unfortunately, that just limits the ability of a system to detect proper temperature. You will make mistakes. These systems will unfortunately cause a lot of false negatives or misdetections where people who do have elevated temperatures might walk right by and being undetected. This example you see where the person removes the hat and the glasses, there's definitely a 1.6 Fahrenheit degree difference where a person can be declared feverish at certain levels. How do we get the best measurement? We did a study in our lab in Sweden where we looked at over 70 of our employees that were coming back for their lunch hour, and they were scanned using the thermal camera. The study showed that majority of the average of the population measured between the 34 to 35 degrees Celsius. However, a small percent or a certain percentage measured in the normal 33.8 or 33 degrees, and some, as like myself, I'm typically warm, measured in the higher temperature, 36 degrees. This percentage of populations, typically when they have fever, might not show fever in the high ranges as we normally see. They might be more in the 36 to 37, which is not your typical fever temperatures, but compared to the population, it would be considered higher than normal. So the idea of using a system with a set temperature of a fever can be a little challenging because, as I showed, as I mentioned before, some of the factors like age, fitness level, time of day, your stress level, your health status can all affect your internal core temperature. To account for that, you might see some people say they use a black body reference to improve the accuracy of a camera. By doing so, unfortunately, we don't agree with the black body system. You can if you need to, but it's not necessary. You're actually adding another point of failure to the system. By adding another component that has to be calibrated and adjusted, and also it can be tampered with. That is a critical point. You are creating a failure point. These black bodies are limited in their capacity. They also have an error ratio, and that error is going to be introduced into your measurement. So you might be getting closer to the accuracy of the temperature measurement, but you're not actually getting better improvement detection with the camera. That's why our cameras don't need an external black body for correction. Our cameras are precise. When we did a repeatability of measurement study, within 0.15 to 0.25 degree Celsius. That's how accurate are without any correction of any sorts. We developed a screening mode over the years since the SARS outbreak where we realized doing a set temperature to measure core temperature is not necessarily recommended. As I showed you in the population, you can have variances. One way to adjust is to create an averaging. So our cameras, you're able to average out to what you're looking at. from 3 to 10 people. So the system, when it's operated by someone, it will ask to sample up to 10. This would be your baseline, and the person would program a deviation, usually 1 degree or 2 degree over the average. Then you start measuring. In this example, we introduced a recent firmware update where we've now added silhouettes to kind of help people position themselves. It's not improving the accuracy, it's just kind of guiding someone where to place themselves. You can turn it on and off. This is a 1 meter silhouette, but we also have a 2 meter silhouette that we'll show you later on. Recommendation obviously is remove the glasses, put something on the floor to kind of mark the distance to where you want to measure. So what do you want to consider when you're designing this? The tear duct by ISO guidelines was considered to be 3 by 3 millimeters. When we're designing a system or choosing a camera, whatever it may be, between handheld or fixed, we recommend in the calculation that it would be 1.5 millimeter per pixel. This is something that FLIR or ITM personnel can help you with. You don't have to do that yourselves. We will be glad to help you out. We just need to understand the situation and we'll say this is the best recommended system for your application. The camera only needs 200 milliseconds to scan a temperature, so it's a very quick process. It is recommended though to put a sign saying please remove your hat and glasses or something to indicate to someone that don't take off your glasses, because it will not be able to measure accurate. You'll still get a temperature measurement on the skin, but you're not getting the close inner canthus temperature measurement. We recommend when you're setting a range, that's something we can explain to you, the range of 30 to 45 degrees. One thing that is key is, now I said before 0.15, 0.25, we actually print it out as 0.3 degrees, plus or minus 0.3 degrees accuracy without the need to add an external black body. Definitely, you can if you wanted to. Some systems can work black bodies and you can get probably 0.1 to 0.05 degree accuracy if you think that's necessary, but it really isn't necessary. You don't need to add another component of system of failure. Each camera you can create samples, and it will get, some cameras will give you a note to say sample every 60 minutes. Some of them can be operated for over hours as well. We did an investigation. We saw your amortization for the cost of system. It's about 25 cents a person you're going to be calculating. So for the investment that you're putting into these systems, you will recoup very fast the cost of amortizing on the camera. One thing to go back to, if you ever want to look for third-party reviews, and that's something everybody does these days. Whenever we're buying anything, we do reviews. There's a website called IPVM. They're doing reviews of everybody's camera systems, from FLIR to all manufacturers. Please have a look. They really give you some interesting perspective. They do great reviews in everybody's systems. And it's not positive, negative, it's all there, and it'll help you out. So it's a great place to find information about different systems offered in the marketplace. So the benefit of our system. We have a solution for everybody. There is no limitation. We have a handheld temperature gun, fixed cameras, handhelds of all types. The cheapest solution we offer is the IR200 temp gun, which only measures forehead temperature. The problem with this system is, and it's a good unit, but you're under the 2 meter guideline recommended by the government. Whoever is going to be using this must be wearing a protective shield and mask and PPE gear, because you are inside the 2 meter guideline, and you're exposing the unit to contaminants as well. Versus the handheld cameras, you can do all this safely from 2 meters or beyond. Example of setups. On the left-hand image, we call it an image of the one-to-one setup, which is the fastest deployment. If you need something quick, rapid, because you have a group of people, let's say you're a hotel welcoming a new meeting for a committee or something, and you don't want to have anything permanent, you just want to have something fast. This could be a setup. You'd have a portable camera installed on a tripod, and you can add a TV screen if you want to kind of guide people where to stand. If you want something more permanent and fixed and screening one-to-many, we call it, then a fixed camera option might be best. In the one-to-one screening, basically you can have different rows with an operator looking at people. If they've done the sampling, you can we did a calculation. You can have as many rows as you need to, if you like. We did a calculation and we said an average you can do 12 people per minute, 720 people or employees per hour. If you have 4 rows, you can actually do up to 3,000. So very efficient, fast response system. If anyone is detected that is higher elevated or outside deviation, then this person can be put into secondary screening or asked to go home or don't come into the area. The system would basically, of a one-to-one quick deployment, would be a handheld camera of some sort, a tripod, and an optional TV. The TV is only to guide people where to stand. That's all. They don't need to, but if you want to kind of show people what they look like in thermal, this would be very handy to have as well. It's just an adapter that is included with the camera, and you just connect it to a TV. For the one-to-many screening, the fixed cameras are all network operated, so they just connect with a Cat5 Ethernet cable to a guard station. So if you have any kind of a VMS or guard station that is looking at multiple monitors, they will work with your security system. They can be connected from remote distances, and the person can do everything remotely. You do not need to be next to the camera. If something is detected, they can be programmed to be sending a signal to a secondary system, and the person can advise whoever is walking in to say, please go to secondary screening or go home as an option. The system setup is the camera. The simplest system would be a camera with a PC, tripod, or some type of mount, ceiling or wall mounts. Or if you want a more full solution, these cameras are all ONVIF compliant. They can connect with your existing security VMS system like Genetec, Avigilon, and Milestone, and so on and so forth. You can actually have a secondary visual camera as an optional camera into the system as well to give you both the thermal and visual side by side on two screens if you like. So the idea is for a fast deployment. If you have a situation like a hotel or you have a company that has multi-entry points and they want to disinfect these points because you have a high number of people coming in. Let's say you have a morning shift, you have 300 employees starting. You want to disinfect that area, but you don't want to keep, exposing that area for the people. You want to close that and open up another entry. A one-to-one system is very ideal. It's quick, it's fast. We just have to choose the right camera depending on how much distances there is, how much space there is. We would choose the camera and the lens combination for you. But all you need is tripod, and that's it. The camera runs on batteries and comes up with everything you need. If you want a more permanent system that can be integrated into your HR with facial recognition and to be connected to, for historical facts and all that, a one-to-many fixed cameras would be the best option for you. If we look at the two models of fixed cameras now, we have two models, A400 and A700. A400 is a 320 by 240 camera system. The A700 is 4 times the resolution with 640 by 480 system. Your web screen would look like a similar view right here. You have a thermal view with temperature measurement, and you can also turn on and off the silhouette, or you can actually switch it if you have the visual camera included to a visual camera with an overlay of temperature measurement and thermal for identification. If you connect it to a VMS system, you can have a thermal view and even the visual view. This is what you would see, your averaging, your deviation, and the temperature measurement as well. Our cameras, so in typical times before COVID, what were the fixed cameras used for? And this is something to tell customers that your investment can be repurposed for something else. You are not stuck to a specific system that just does one thing. It cannot be reused for somewhere else. Process control. Our cameras in the past were used for process control, make sure something lined up. If you have a situation where you cannot have a visual camera that is because there's lights and reflections, so on and so forth, a thermal camera does not get affected by light. It's looking at temperature differences. Huge advantage. You can have a complete black room with nothing in it, nothing showing it, and no lights, and the camera will still see temperature differences. Quality assurance. This is a manufacturer that cooked food. This is cooked chicken wings, and the company wanted to know if the wings were cooked or uncooked. The old method, they had an operator picking a sample throughout the line randomly, and if they detected anything out of spec, the whole batch was thrown out. Quite costly. One method they used to adjust, they would increase the temperature of the ovens to kind of make sure that everything is cooked, but the problem is you're wasting energy and sometimes you're not getting good product quality. With a camera, now a thermal camera doesn't know what a chicken wing is, but it was connected with a system that learned. It was an external system offered by third party that learned what the shape of a chicken wing, and it was able to detect every single wing automatically. You can imagine how it improved the process for the customer. They can run much faster, 24 hours a day, pick every single one, create historical data, record all this data, go back and view it, and save energy. All kinds of feature benefits for having a system like that. Condition monitoring. If you have a situation where you have a critical vessel or critical equipment that they're very temperature sensitive, they have to be within certain set parameters, you can mount a fixed camera that can be connected remotely, and these are all powered by PoE, and you can set an alarm condition that if anything changes from out of spec, it will send a signal. Perfect example and biggest market for our fixed cameras is the early fire detection. In this example, we have a pile of tires. If you have a company where you have a warehouse with dangerous chemicals or piles of any types, ammonia or wood pile or tires where there's risk of fire, having just a smoke type detector system is not ideal because by the time the system detects anything, it's too late, there's a fire. The advantage of a thermal camera is you're able to detect rise in temperature way before the combustion point. In this example, if we look at the pile of tires, let's say the tires combust at 500 degrees C. You're able to set the camera looking at a pile, program it that if it rises above the ambient, let's say ambient temperature is 20 degrees, you don't want anything to rise over 60. So before it even gets to combustion point, it sees an early temperature rise. You send a signal to a monitoring station to notify someone, and then you can react. It's a huge cost benefit to a lot of industry and companies out there. For the handhelds, which have been used for a long time, we've had our handheld cameras for many, many, many years, basically since the early 50s and 60s. Electrical inspections, very common. Panels, fuses, bus bars, building inspections. Windmills, building inspections looking for missing insulation. So for the building world, you're looking for water infiltration, roof leaks, missing insulation, something, any kind of strange anomaly, you would be able to find it with a camera. Solar panel inspection, circuit board inspection, and many more applications out there. Now we get a request a lot for non-EST, the cameras do not have the averaging mode. So the cameras I just showed you, except for the IR200, all have that averaging method where you're able to create a live baseline to look at what's in front of you and then adjust for any variations throughout the day. We have cameras that can still do temperature measurement, but without the averaging. You would have to do your own manual averaging, basically. You'd have to have a file, an Excel file, or some kind of writing that create your own average, which is the best way to do this kind of measurement. If we take the FDA approved minimum camera, which is the E75 with a 14-degree lens, and use it saying, okay, this camera has a resolution of 320 by 240. With this lens, can measure the inner canthus accurately at 2 meters. If we use this as our comparison camera, how does the other systems compare? The most common system that we get asked about a lot because of price point is our FLIR One. This is a phone adapter right here that connects to various models of phones out there. That people say, why can't I measure temperature? It can measure temperature, but not as accurate, not as precise, and you have to be 6 inches away, 15 centimeters away from the face of the person to get as close to the resolution of the E75. You're way under the 2 meter recommended distance. You're exposing yourself to the virus and you're contaminating your device and the adapter as well. So you're not saving, you're actually endangering yourself in that case. These systems are not FDA approved. The C5, which is introduced recently, 9 inches, same thing. No averaging. You have to be very close to the person to get as close to the accuracy of the higher end models, and everything is manual. Very dangerous at that point. E5 and E6 cannot be used. We have these models, we've had them for a number of years. They just don't have the minimum focus distance to get it as accurate as the E75 is under with their capability of. So you won't be able to get it. They don't have a focus adjust, but they have infinite focus. But if you get too close, you'll not be able to use it. It doesn't measure accurately. You're going to get off measurements from this camera. The only one that is similar that has a removable battery is our E8, but that one you have to be at 22 inches. So again, if you compare it to the E75, you have to be, which is at 2 meters. This is 22 inches. You're under the 2 meter guideline. You're exposing yourself and the equipment to contamination. We have an E53, which is model similar to the E75. Again, it's kind of an in-between. Some people would just want to use it for price point, understandably, but you still have to be 32 inches. It will not be as accurate as your higher end models. Are we good on so far, Chris? Any questions that I need to address before I continue on?
Let's see. We do have a question to elaborate a little bit or explain the screening mode that sure. Maybe would be a good idea to go over right now.
Yep. So what I'll do is when I go to the camera, I will get into it in depth and all that because it'll help explain that better when I have a camera connected live next to me and I can show that as well.
Fantastic.
I'm actually done. I'm almost done. I got a few more, like 3 more slides and I'm done. Just to summarize, FLIR has been doing this for a long time. We're the world leader of this. We have a great service center and support in Canada and worldwide. Our cameras are built in Europe. We have a plant in Sweden or Estonia, depending on which model. We're meeting demand as fast as we can. We're getting extreme, massive demand that is unseen before to meet with the marketplace. Our cameras are FDA approved, and by inherently, they are 0.3 degrees accuracy, plus or minus, without any correction or data manipulation. Last week, we introduced a new software called FLIR Screen-EST, which will make detection and averaging much more easier. I'm going to explain that to you as well. I'm going to do a little demo on this software shortly. And the nice part is multi-language automatic averaging. You can save the images and lots of great features. It's going to give you basically, so you're going to have two screens. There's an operator screen, and there's another screen that is shown to the people where to stand if you're too close, too far in good position, and you'll get a read. It'll say nothing detected or elevated temperature detected. The questions that I ask generally to the customers, which we'll definitely open up to everyone else. What is your greatest risk factor? What type of business are you looking at to the risk? If you're a grocery store, you have a higher risk factor because you cannot control everybody coming in. And usually if someone is infected, they'll come in and they're usually if they keep their social distance away from everybody, and they leave within 30 to 45 minutes. So they tend to be not as interested in the hiring system. They want something inexpensive. If you're a company where you're a production facility, where you have people, or an office building, where you have people working side by side, very close to each other in a closed environment, you have a much higher risk factor. So you want to consider a good solution that is catching as many people as possible and reducing false positives or false negatives. The worst thing you want to do is install a system that's going to give you, miss everybody who might have potentially, or a majority of people might have higher temperature, or give you too many people that have high temperature. And what does it look like? What are you trying to do? Is it a one-to-one fast deployment? Do you want a fixed system? And what is your time frame of implementation? Those are the questions that I like to ask. So thank you for I'm going to say thank you for the PowerPoint portion. Now I'm going to go to the slide portion of this. And I want to thank ITM for setting this up for us. I really appreciate their help on getting this message out to the market. So I have a camera with me. I'm just going to undo my PowerPoint. Not sure what happened to my screen. Oh, there, 1 second. Lost my screen here for a sec. I have a camera connected to my computer. It's the T840 model. In regard to the screening mode, so our camera has a mode built in the E75, E85, 95 that allow you to create an averaging method. So as I mentioned before, the best area to measure temperature is in the corner of the eye. And the best way to do it is an averaging method. The averaging method allows you to update. So if there's external factors, when I started the presentation or the seminar, the webinar, I had just come from a kitchen upstairs. The windows are open. I'm a little bit cooler, but now as I'm sitting down, I'm getting warmer. I originally averaged out to a cooler core temperature. Now as I'm sitting, I'm getting in an area that's enclosed, I'm getting warmer. That's where you're seeing my temperature rising. So now my averaging has changed. I just have to re-average my eyes, basically, or my face to the screen. I'm a little bit out of focus, sorry about that. Everything is updated now. I don't look I have a fear anymore. Everything is good. Now I basically redid the baseline. Sorry, it's stuck in my mouth right now, where I'm readjusting the average. So all the operator has to do is set the average, create a deviation, usually 1 to 2 degrees, and this is the temperature that's being measured. This is on board the camera. The silhouette is on the camera. You have a 2-meter silhouette, or you can even set up a 1-meter silhouette. You don't have to use it. There's nothing saying you have to. This is just a guideline to people line up themselves. So basically, the person comes into a space, they stand within the space, they line their face. Sorry, I'm trying to do this backwards. They line themselves up as best as they can. The camera measures the inner canthus, everything's good. You go on to the next step. Every now and then, you might get a message saying, please update samples. If the camera detects a change in temperature and it says, you know what, we need to update the samples, it'll put a message, a new sample, 1 or 2 samples needed. You just have to re-update with the person in front of the camera that's healthy and create a new baseline. The nice part about this is if things change, if the environment changes, if it's a night shift, day shift, and there will be changes, you want to update your average because you want to make sure the idea is to eliminate as many false positives or false negatives. If you just set it to anybody who's over 38 degrees is feverish. Well, what happens if it's a night shift? Naturally, people are colder, which means when they're feverish, they won't be at 38, they might be at 37 or 35. The only way to really know is average out. If I have a number of people coming in, typically the person who has a fever will be warmer than the rest. One of these, the expression, one of these things are not like the others. Well, basically that's what you're doing. You're updating your average. There's no need of correction. And only if you notice there's a change from morning. Morning shift is very cold, afternoon shift is very warm. That's when you should update your average. Otherwise, it's not needed. Our fixed cameras would have a very similar setup as well. You have an average, but the difference is where this is done right on the camera, fixed cameras, you can do it remotely. Okay. With the new software, which we introduced last week, I'm going to close this window and I'll open the software. It's called FLIR Screen-EST. We made that a lot easier now. We're just waiting for it to open. So the software is multi-language. It can be French, English, or any. We have 21 languages on the software. This is the operator screen that you're seeing. Sorry, it's a little slow. It's doing its own auto averaging. I have it set to 10. You can set it to many. If you have a large, 3,000 employees or something, you can put it 100, whatever you choose to. We just put it at 10. It auto averages if you want to, or you can leave it at whatever number, where we have kind of an idea of what the value should be at. And the advantage of this, it automatically detects my face. So this window is the operator screen. He will see the thermal image and the visual image from the camera, if it has a visual camera. And it'll automatically follow my face. It's doing logging, so you can actually log all this data, and you can alarm if anything is detected above the temperature, and it'll automatically capture an image and the data. Or you can do manual snapshot as well. This system can't be fooled. You can program it to say, so if a person holds he says, I have a fever, I want to cover my face, or I want to, it won't measure. If you want to, employee says, I want to go home today, I'm going to put a lighter and pretend that it's high temperature. It will know that this is not real, and it'll give you a message. This is outside the spec. You can actually see if I have a lighter right here. You see the message. Oh, sorry, I'm not lined up in the face. Above skin temperature reading. So it says this is not possible. It knows this is not a correct. So the operator gets notified, and somebody's trying to tamper with it. This is what the operator screen they're seeing. You can set it up and let it go. The person standing in front of the camera, if you want to have a TV connected, this is what they would see. This message is telling them that I am too close to the camera. I need to go back. So as I go back, it will follow my face and it scans me automatically. It tells me no elevated temperature detected. If I'm out of the window, this is the window you would get, where it shows you remove your hat, glasses. Mask we programmed it, but we might be able to remove it depending on the need. It's not really moving the mask, it's more lowering it so that it sees eyes, nose, and mouth, not mouth, but as long as it sees that, to be able to capture the face properly. As I put my face back, it automatically finds me. If I was higher, and if I try and fool it, and the person thinks they're fooling it, but the operator sees that it's not true. It says elevated detected, but it's actually the operator sees the truth that this is above way above what it's supposed to be for skin temperature as well. Any questions on this so far?
Nothing that's come in on this particular, on the screening. I think you've done a great job in answering Mansour's question about the screening so far. We do have a bunch of questions that have come in. If you'd like, we can leave them for the Q&A period.
Yep, so I'm all done for the presentation portion, and I'm open for the Q&A.
Perfect. Well, thank you very much. Yeah, thank you very much, Manny. That was a great presentation. I hope everyone connected did get as much information and being able to internalize all that. It is a lot of information all at once, but please take the time right now. If you do have any and all questions, we have plenty of time to field any and all that you have. The first that did come in earlier on talked about the accuracy of the cameras, and I'm going, Mansour, again, probably based on a data sheet, that the best FLIR camera has a ±2 degrees C error rate or accuracy.
Correct. That's so if you're measuring up to the maximum ranges, so 650 degrees C or up to 2000, because some of the cameras can measure up to 2000 degrees C. That's the typical accuracy that you will see in the systems. In the skin temperature range, you will see much more accurate 0.3 degrees accuracy. We actually now officially publish it. The repeatability measure, and you're getting plus or minus 0.3 degrees. You're actually getting better, but to make it more official, we call it 0.3 degrees without any correction of a black body.
Perfect. Another question we have, can either the fixed or the handheld option be set up and used outside, or is it always preferred to be used inside?
It's preferred to be used inside because the issue is some of the pictures you saw, they were set up outside. That was actually more marketing that did that, and that was done in a customer who asked us to set it up outside. The issues is you will have external effects, wind, solar, rain, any of those factors. If you are make sure that you're accounting for these changes, you should be able to use it outside, but it's not recommended. It's always best to use it inside in a control. I actually spoke to a customer. What they've done is they set up trailers. When people walk into a trailer, they have a camera set up, and that way you're controlling the environment. Like anything else, when you want to get accurate measurement, it's best to control the environment as best as you can to limit any external errors.
Absolutely, perfect. Another question we had was about the temperature range, either using the EST software. I'll just reiterate the question. An earlier slide said the temperature range was between 30 and 45 degrees C. Is that able to be altered within the software for conditioning monitoring or QA?
Yes, yes. So what I meant by that is we have different color palettes. You saw me using the black and white. We have all kinds of color palettes, and I can actually switch the screen. Let me just go here. I'll open up the other software we use to connect to the camera. So the range can be to the full range. So my camera has a 3 ranges, minus 20 to 150, 0 to 650, and I think 300 to 2000 if I'm not mistaken. I'm just going to do live. The range, when we say range, is just to allow it to reduce the. I'm just going to connect to it right away. Reduce any external, so it looks clearer to the image and all that. So you're seeing that this is the black and white palette, but I can choose, any color palette I want. And the range is what we say here. This is already set to 20 to 30 to 40. I'm sorry, 20 to 35. You can actually set it to be auto if you want as well. You don't have to be. So it's more of how the color is being looking to the people using the camera.
Perfect. The next question, I believe it pertains more to the A400, A700. It talks about specific part numbers, the T300, 342 and T300, 344, and the differences between the two, and if both need to be used. I'm assuming I looked it up earlier. I believe it's the configurations for the A400, A700.
I don't remember which configurations. I know we sell them. Forgive me, I don't remember the part numbers off the top of my head like that. But yes, so the way the A400 and A700s are sold, you buy the camera core, you buy a lens, because remember there's different lenses for different applications, and then you choose the configuration. If you wanted to use it as for feature detection, it's called the Smart Sensor configuration. That would allow you to have the silhouette option and temperature alarms and all that. And easily accessible through the web. If you wanted to have a system where you connect it to an access control panel, so it opens and closes doors or records historical data, so on and so forth, we have a gigi version. Now, the nice part is one camera can do 2 things, can be reconfigured. Before, you used to buy one or another. You can buy one camera to do 2 things. Now you can buy one camera, configure it one way. Later on, if you want to repurpose the camera in a process control or like the chicken wing example, you can just get it reconfigured to do the gigi, or we call it a GeniCam GigiVision streaming. Same camera, same lens, nothing changes. It just makes a lot of huge savings instead of having to buy another camera.
Perfect, thank you. So let's see, next, do you offer cameras with enclosures that are good for hazardous or dirty environments like mines, mills, manufacturing plants, etc.?
We do have some enclosures. If we don't have the right one, we can find one that is recommended for the environment. So we've done it before where we've done projects where the customer wanted stainless steel enclosure because of high temperature issues or so on and so forth. So we have some, and what we do is as long as there's an IR lens on the enclosure, because infrared doesn't pass through window. What I have beside me right here is a glass door. It's a frosted glass door, but a camera cannot see through this. To it, it's actually reflecting. So if using a standard enclosure with a regular glass lens will block everything. You need an IR lens. Our enclosures have them. If not, some manufacturers out there, Videotech and Pelco and all those, will have variations that allow infrared energy. Let us know the environment and we'll research out and figure out, is the enclosure fit your need, or do we have to recommend another model?
So to follow up with that question, you can reach out to ITM directly and we can pass off and work within our sales department to make sure that we get you the exact solution that you need. Next question from Rodney. Does the Canadian government have approvals for FLIR IR FDA, and is US approval correct?
I'm sorry, I don't understand US approval correct. Okay, so I'll answer the first portion. We are finalizing the Canadian Health Canada licensing. We should be getting it. We got the notification, they looked at it. It's unfortunately taken a little bit longer than we expected, but they're looking at it right now, and we should get the approval, I would say, within this week or next for Health Canada. We do have, if you need the Health Canada license, we have one partner who ITM can work with that did get their licensing as a full system, but they're not just using our camera, they're kind of using like a detection system connected to a door and access and all kinds of things. It's a more full turnkey solution versus just a camera and a system and all that. But FDA has been approved since 2004 for our cameras.
Okay, I think that's where the US approval is more leaning towards. A question from Wesley. Are there any eye safety that needs to be worn when using these types of cameras?
No, and that's actually a great question. Thank you, Wesley, for asking that. There is zero emissions from these cameras. The cameras do not emit any kind of rays or anything to detect. This is not X-ray. It's actually absorbing everything that is being emitted to it. So the way it works is it's an infrared sensor. It's a little detector. There's many minuscule detectors side by side that absorb whatever energy it gets. And that energy intensity, we convert to a temperature value. Now, keep in mind, there are some companies out there that use infrared, similar technology to this, not the green one. So there's misnomers out there in the world what infrared is. Sometimes they'll call it a night vision, where they use a green view and they're amplifying light. We're not amplifying light. If I turn off the lights right now, you will not see anything in the visual, but you'll still see me in the thermal. All I'm doing is the temperature difference being picked up by the detector is we program intensity, and then we calibrate it to represent a temperature value. That's how we're able to measure accurately from safe distances away. We can measure targets depending on the lens and the configure and the resolution, 60 feet away, 100 feet away, depending on what it is, but very accurately. That's one of the best things about our system. We have drones that have cameras now that are used for scanning from far away. So you can imagine the accurate, and our helicopter, you've seen our cameras being used in the police, law enforcement, and in military for a variety of applications. A lot of, unfortunately, Hollywood makes a mistake. They say thermal can see, you'll see a lot of movies where they use FLIR cameras seeing through walls, and they can see there's a whole bunch of people on the other side of this. We don't see through surfaces. There's no X-ray capability of these cameras. Unfortunately, that's a misinformation by Hollywood, but what can you do?
It's a great explanation, thank you. And yes, thank you, Wesley, for the question. Next question comes from Dave. I have a T530. Is this suitable for this type of application?
Yes, and the lens, so a T530 is actually the best resolution. If you have with the right lens would be a 14, if you want to do the 2-meter scanning, it would be a 14-degree lens. If you have a 24-degree lens, it's a little under the right resolution. You're not getting as accurate. So the nice part about the new platforms, you just order the lens from ITM, install it on your camera. You're ready to go. There's nothing else to do. Mm-hmm. There's a process to kind of realign the visual camera to the thermal. It takes 30 seconds, and that's it.
Perfect. The nice part E75.
Sorry, the lenses. The nice thing also is A400, A700, T500, T800. The lenses are interchangeable. So if you end up buying a handheld and a fixed, and you say, you know what, I want to use this lens for my handheld model, take it off, put it on the hand. It's one lens can serve multiple cameras.
Perfect. Another question about a camera. Does the E75 EST mode display the silhouette?
Yes.
So that's applicable basically on all cameras
Correct.
that use
so
the EST
all the
software.
all the AXX, T5XX series, T8XX series will now have the silhouette ability. Again, it doesn't improve the accuracy. It's just a guide. You don't have to use it. You can adjust the zones. We use, so for me to measure temperature, we use tools called, let's see if I can use them. Where's the tool? Oh, right here. We have a spot. You can put a zone. Now on the camera, you only have a zone, ellipse, or a spot. And the ellipses, anything that is zone shaped can detect automatically the cold and hottest. A spot, you have to move it around. But most of the time for the EST mode, everybody's just using one zone. that can be resized. If you don't use the silhouette, you can resize it to any shape you want. Every pixel is given temperature measurement. And the nice part is any image you capture is just a JPEG image. So sharing it, it's easy to share. There's nothing to convert. But with FLIR software, any image you capture, like I'll show you the images I captured last night, you can measure the temperature anywhere you want after the fact, and so everything's saved. There's nothing lost of data. Everything is still there. Easy to share, easy to measure. They're JPEGs, but with software that you can, and then you can create your report. You can create profiles. You can create anything you want. And some of the handheld cameras actually have the GPSs. So if you ever want to record, if you're outside, it doesn't work very well indoors, especially in factories where they have metal roofs. It'll record your coordinates and show you where that picture was taken as well.
Another question about the software and a camera. Is the EST software available for the A400 camera?
It will be in another week and a half or so. They're just finalizing the beta testing right now.
Perfect. John has a couple questions. One, how to connect to a screen, a monitor, the option monitor that you were talking about?
Yes. So if you're just using a handheld, excuse me, if you're just using the handheld camera, all the cameras come with an adapter to connect to an HDMI monitor. You just plug it into the USB-C port of the camera, and you run it to an HDMI, and you'll have it right on TV. If you're using FLIR Screen-EST, your computer would be the one connected to the monitor. However, all you would share on that monitor would be the secondary scanning screen, not the one the operator sees.
Perfect. And next question again from John: is the optical camera compatible across multiple thermal camera types, are they one-to-one? I'm assuming again the optical he's talking about the A400, A700.
I don't understand the question. Sorry. Is it compatible? I don't.
This might actually, and you touched on it earlier, is maybe the lens itself, the lens and how you touched on how they're intertwined and interchangeable.
Correct. So the lenses only affect the thermal detector. It doesn't touch the visual camera. Is a set. Sometimes they're 5 megapixels, sometimes they're 3 or 1, depending on which camera model. But there is no lens. It's the lens I'm referring to only applies to the thermal detector.
And John, if that didn't completely answer your question, please jump on in the chat again. We'll elaborate further if need be. So next question from Brett. Is there a 4 to 20 milliamp HART output available on the cameras for outputting a signal to a separate device?
It can. You just have to buy a device. My engineers mentioned to me. I don't remember the name of it off the top of my head, but it can be. It's very easy to do. It's not our old models. You had to buy a module that was about $2,000 to $3,000. Now you can buy something for $300 and it'll give you the 4 to 20 milliamp conversion. I think it doesn't actually provide. It provides a direct contact, but not the actual current. So you just have to connect it to something that does the current 4 to 20 milliamp. But at my engineers, I can ask them and they'll send me the name of what it is.
Perfect. Another question from Mansour. For an outside, I'm assuming an outside setup or outside application, let's say, would a black body be recommended?
Not really. You're just adding another point of failure. The black body is going to be influenced as much as the camera by external factors. So in the image I shared here, what is a black body normally used for? Let me go back to that PowerPoint here. Let me close this. And a black body is typically used to calibrate an infrared camera to the, sorry, it keeps going to there. Everything you see here is a black body that has a set temperature. What we do is the camera is pointed at the black body, which is you see on the screen, and that temperature is pretty much fixed. It has a high emissivity that allows us to make sure that whatever camera reads should match to that temperature. That's what they're typically used for. The thing is about a black body is they're not intended to be left on 24 hours a day. They're not intended to be used in that methodology. These are highly accurate black bodies. We get these ISO certified annually because when we make our specifications, we want to make sure the cameras are within spec. The systems that we've seen out there that's being offered as a black body are not accurate. They have a 3 to 5% error ratio, which means that you're introducing, even though you're getting the camera to read more accurately the temperature of the black body, but the black body itself is inaccurate. it's not accurate itself. There is errors. So whatever error it has is being introduced into the measurement. And if there's wind, it gets introduced back into it's going to affect as much as the temperature read. And another thing is when you're measuring temperature, you have to be in the same plane, meaning the same level. If I show you the screen right now, if I'm out of focus, let me do the presentation, go back to this window. If I'm out of focus, so I'm going to look at the camera. I'm kind of in focus right now. It's measuring 35.7. I'm just a little bit out of focus. Sorry, I'm still pretty good. Much better, but it's fine. Let's do the 2 meters. Hold on, I'll do the 2 meter distance here. It's actually much better than I thought. Okay, there's a drop a little bit and all that, but the more out of focus you are, though, it's gonna. So you have to be on the same plane. They recommended is you gotta make sure you're always on the same plane, same level. If the black body is 3 feet behind you because you don't want to contaminate it, it's not. You're focusing on the black body, not on the person. Oh. And remember, the black body. And I was talking to a customer. I can't say who it is, but they actually said it. It says if it can be touched, it will be touched. You know the expression is "don't touch." You know when we were kids, parents tell us, "Don't touch that." What did we always want to do? Touch it. So that means if it can be touched, it can be manipulated, it can be broken. So we don't recommend using a black body.
Perfect, thank you. So folks, we have a little under 10 minutes left. If you have any questions, please get them in now. We do still have a decent amount left to cover. So any last minute questions that you want to get covered, please enter it into the chat. If you don't get your your question answered or covered, you're welcome to reach out to ITM and we can work with any and all questions. To your point, and talking about calibration, Faoud asks, do any components need to be calibrated periodically?
Good question, Faoud. So I'll give you an example. Some of the nuclear utilities, nuclear generation facilities across Canada, they internally have a program that everything has to be recalibrated every 3 months because this is the type of program that they have. Anything that measures something has to be recalibrated. So the question, what people ask is how often should cameras be calibrated? It's up to you. It's not. We recommend 1 year, but nothing says you have to. If you're asked by the insurance company or you have an internal program that says everything that measures something should be calibrated, then you follow the guidelines. But you don't have to. If you respect the camera operation, you're not dropping, kicking, throwing the camera, or leaving in minus 30-degree weather, or putting in high extreme temperatures where you can make the camera deviate, everything should be fine for a long time. We see our cameras are still being used that are 20 years old and they're operating perfectly. There's no issues at all. So it's really depending on the way the camera is being used. However, if you don't feel comfortable, you want to make sure you are accurate, then you can certainly get it. Now, ITM offers a calibration check service, so you don't always have to send it to FLIR. FLIR recalibrates to the factory spec if anything's out of spec. But if you want a quick check, please use ITM. They offer a service where they can check for you, see if your camera is within parameters.
Perfect. And for the next question, and just taking Manny's answer a little bit further, for any quote requests, inventory requests, pricing, anything like that, you can send all your requests and RFQs to information@itm.com, and one of our sales reps will help you out. So Chris has a question about the software, it being a one-time cost or a subscription and periodic cost.
One-time cost. So the software, there's actually 2 parts. There's you have to upgrade the customer who asked with his E530. You have to get an update. You have to purchase a firmware update that allows you to do the dual streaming of the thermal and visual. And you have to get the software for the PC. Both are one-time costs. Perfect. The exact value, I don't have the exact pricing yet. I'm getting it hopefully by the end of day today, but I think it's close to about combined $2,500.
Okay. Rodney asks about the 14-degree lens versus the 24-degree lens and which is better for handhelds. Example, E75 14 versus E75 24-degree lens.
So if you looked at the ISO guideline, ISO stipulates that the inner canvas measures about 3 by 3 millimeters in size. To get a camera with a pixel size, if each pixel represents 3 by 3 millimeters, it'd be tricky because you want to make sure you get that pixel right on. So we suggest when you do your specification to use a 1.5 millimeter per pixel calculation to make sure that we at least get 2 pixels on target. The more the better. The more pixels you get on target, the more accurate you get a measurement. To make sure that you're not catching anything outside the spot, for example. But if we use 1.5 millimeters as a guideline, the 14 degree would be the best option for an E75 at 2 meters. If you don't want to install the camera at 2 meters, nothing says you have to do it at 2 meters, but if you have an operator manipulating the camera, they're trying to keep themselves at the 2 meter distance. That's why we recommend 2 meters.
Perfect. Question from Jonathan. For a workplace that some days may see 4 people, the other days may see 100 coming in through the doors, what would be the best method for skin temperature readings? Change the average each day accordingly, or maybe create a new baseline periodically using a healthy person routinely?
So if you don't want to buy the Screen-EST software and you just want to have a fast deployment, you have multi-entry points, you don't have the camera running all day. It depends on, honestly, on your, well, that was one of the questions, what do you envision the system solution to be? Then a handheld, minimum is Z75 with a 14 degree lens, do a 2 meter distance. That could be, and the averaging, if there's temperature change, every time you turn on the camera, if it has been on for a while, it will ask you, please update, give us 10 averages. You can use, we suggest 3. I've done it with myself with 1 person. If the person's healthy, it's a good way to create a baseline. You just want to update it to see that if you start seeing, if your crowd is coming in from a cold parking lot, let's say it's cold outside today, that means potentially the person who might have a fever is not at the 38 degree or whatever the set standard temperature would be for a fever, which means you might miss that person. To reduce that risk of getting a false negative, meaning a person who is higher fever, but you didn't have the right settings, you average out. So if you are inside and your temperature is normalized, but people coming in are cooler than you, you should re-average. If they're warmer than you, where everybody who might have fever, everybody's going to show you like they have, so everybody has a fever now, which is what you want to do. You want to re-average, you want to increase your average set point to reduce that. The idea is we don't want to make it too easy to let everybody who has a fever through. We don't want to make it too hard to make everybody look like they have a fever, right? You're trying to reduce that effect as much as possible. Best way is to update your average. So the answer is difficult to answer because I don't know the situation and the conditions.
Understood. That's a great answer for not knowing exactly the specifics of what it is. Keith has a question about inventory and lead times. I was told by our organizers that my mic was cut off in the beginning. So Manny, I'm going to let you touch on this, and then I'll elaborate a little bit with ITM. Are you experiencing any delays in delivery to customers related to demands for any of the thermal imagers?
Correct. So I won't hide it from you guys. Yes, we are, because it's not because we cannot supply, it's because we're getting massive orders. The issue for us is we're not being, it's unexpected. We got an order 2 weeks ago for 1,000 cameras. We got another order of 300 cameras. When these orders come in and we don't, we're trying to produce this. Our cameras are produced in Europe. We have factories running in Europe. We have 3 shifts running in Europe and Estonia, actually. So Sweden and Estonia producing these camera systems as fast as possible. We've increased our credit from our suppliers of our raw material by 5-fold. Everything's been increased as fast as demand. The issue is there's no predictability. I might say our lead time right now, we are improved. We got note on the weekend that our lead times have improved, will be improved significantly. It was 8 weeks, we might be able to do much better. But if we get an order for another 1,000 to 2,000 cameras this week, it's definitely going to impact the orders. That's something that we can't control. And we are seeing massive orders these days that we've never seen in the history of FLIR in such a short period of time. As a planning, how do you foresee what the demand, if we have a certain set line with production lines running and then we get 10 times more demand, we try and ramp up, but at some point we can't ramp up as fast because we keep getting more demand on. So it is improving quite a bit. Best thing to do is get your order in as soon as possible. We do our best to get you the systems as fast as possible and for your need. We are giving priorities to health facilities. So if it's a hospital, seniors home, they get priority. You put it in the order, they get put on the top of the production planning, say this customer is for this. And then we go down a list from government, schools, and so on and so forth and all that.
Perfect. And just to elaborate on that, for any and all who are interested, as I mentioned, you can email information at itm.com for any quotes, any lead times. ITM does have many of these cameras on order right now, so that we will have stock to be able to fulfill orders as they come in. So to Manny's point, if you're interested in this technology, reach out to us for a quote. We'll get you all the information you need, any technical specifications, any questions that you have, and we'll try and get these on order as fast as possible so that we can cut these lead times down as much as possible for you and get these set up with you. We have gone right to the very last minute. So Manny, thank you very much for sticking with us. Thank you for the presentation and answering all the questions. Again, if we weren't able to get to your question or answer it to the best of our ability, and you have more follow-up information at itm.com. On behalf of ITM University, I want to thank you very much for attending our webinar. We are available to assist you, as I just said. Visit our website, itm.com, itm.com/FR for French. If you need anything, please contact us, again, using the email address information at itm.com. In a couple of minutes or a couple of seconds at the end of this webinar, we are going to have a short survey that we'd like you to complete. Please do so. Your feedback will really help us in improving and allowing us to bring more topics of interest for you and any of your customers or anything related. Don't forget, as a thank you for attending our webinar today, your name will be entered in the draw to win $100 for your next online order. The winner will be announced via our social media channels, so be sure to check us out there. Again, Manny, thank you very much for the presentation. It was fantastic. Thank you all for joining us, and we wish you a great rest of the day.
Thank you, everyone. Please stay safe and have a great day. And thank you, ITM, for setting this up, by the way.
Thank you, Manny.